All right, guys, welcome back. Hope your chapter 9 assignment went well. We can talk about it on Wednesday if you have some questions. So stay with it if you need to. And then today I'm going to do sections 15.1 and 15.2. All right, so you can start working on those. I've already posted section 15.1 definitions, which I'm showing you right now. And then I'll get 15.2 posted very soon. So you can start working on that as well. Although if you check your due dates, you have a little bit of time. So on this 15.1, I can't get that to be more focused, so I apologize, it doesn't look great, but this 15.1 is just definitions from this section. So I just asked you to go ahead and read that section in your book and then answer these definitions in your own words and include an example with them. All right, so I don't want you to use the same examples in your book. I want you can research and find other similar examples, that's fine, but I want you to show me an example of those and then write your definition again in your own words. All right. So that you can check the due date on your syllabus when you need to turn that in. So that's all section 15.1 is. And it talks a little bit about also how to determine if a question is a good statistical question. So pay attention to that in your reading as well. All right, so section 15.2. So this is this whole bit is on statistics, and we're going to start kind of with these maybe middle grades, grades 4, 5, in there. We're going to begin with that. Sorry, I'm still trying to get this a little better focus for you. And then from there, we're going to go ahead and do a little bit higher level with our standard deviation and so forth. And we're also going to talk about the MAD, the mean absolute deviation, that there's lots of controversy over, so we'll have that conversation as well. But 15.2 is mainly just talking about different ways to display data, all right? And there's two types of data. There's categorical and there is numerical. So categorical are just the types of graphs that show it in categories more or less. Doesn't mean you don't have numbers in it, but it's more about categories. So when you talk about a pictograph, I'm just going to quickly talk about these. I'm sorry, it just drives me crazy that I can't get these more clear. Ooh, how about that? Just a little bit of. All right, let's take a look there. All right, so a pictograph is a graph, obviously, that uses symbols to represent your data. Okay, it shows the frequency of something. And it just kind of lets you compare items. Like on this, you can compare the different fruits. And these are smiley faces. What's important on the pictograph down here, though, is that you have a key that says, for example, this one is 1 vote equals 1 smiley face. So be sure that you have something like that. You could even sometimes throw in a fraction on that, and that makes it a little bit more challenging for students. Like maybe 1 smiley face equals 1/2 of whatever you're talking about. Okay, maybe it's one smiley face is equal to 1/2 mile, something like that. So if you want to make it more challenging, throw in a fraction with that. All right, so bar graphs, you're probably familiar with bar graphs. They show the frequency. Okay, they're categorical. And instead of doing a pictograph, it shows bars. So just to show you up here on my pictograph, if I just made this a bar right here, that would be fine too. That's just a sidebar graph. So you could turn that pictograph into a bar graph. Now, of course, you'd have to have your values. You're gonna have to put your values on there, but you could do a side graph with that as well. It allows you to at least visualize seeing that. So here again is with the bar graph, and so each length of your bar indicates the frequency of that particular category. All right, so these are different movies, the amount of people that went to them, a comedy, action. So, it still has numbers involved in it, but it's really about comparing the categories. Right, so when you're comparing various items, you're going to use a bar graph. And this is just a double bar graph. Just means in this case, maybe we had data that were both, in this case, camp activities, and so there were boys and girls. So we wanted to do both of them. So you can see how I can compare that data as well. So that's a double bar graph when you have two different categories that you're comparing. All right, so pie chart. So take a look here when we do a pie chart. it's just it's a circle. Okay. Similar to slices of pie or pizza, when you're talking to younger students, you could kind of compare it to that. But it also compares different categories as well. So I'm going to show you how to write. So you really, like in a pie graph, you can compare percentages, parts, depending on the information you're given. Sometimes you can only do percentages and degrees, okay? But once, and you can also, if you're given total numbers, you can include the number as well. But not always will you have the total number in there. It just kind of depends on what kind of pie chart that you have. All right, so I'm going to show you though, what I would expect you to be able to do on this is to be able to create a pie chart. So the steps on that, I'm going to go through this real quick, but I'm just going to write on here the different steps that I would expect you to do. And I'm just going to do a quick example here off the top of my head. So let's say we have 100 musical students. We'll just say we have 100 musical students. Not super creative on my part. Okay. And let's say we have band students. We'll have choir, maybe both, and then neither. That might be what our categories are. Okay. So what I want to know is how many, let's say that I have 40% in the band, and let's say 10% in the choir, 30% for both, and then, well, 20% left there for neither. Okay. Now, I want to create a pie chart where I can use these percents, but recognize percents add up to 100, right? And circles add up to 360. So we're talking about percentages, and here we're talking about degrees. So what we have to do is we have to convert these percentages to degrees before we can create our pie chart, all right? So our next step then is to convert. Let's go ahead and, first of all, tell me how many students would that be, just so we know that. If I have 100 students and 40% are band, that's going to be 40 students, right? This would be 10 students, 30 students, and 20. And that's just 20% of 100 is 20. Okay. And then the last thing, let's go ahead and put it into degrees. So I might want to put here that we have, this is the percent, this is the number of students. If you can read that, sorry, that's pretty sloppy. And then here is the degree. So how we find the degree is we're going to take 40% of 360, right? Because we want 40% of what that total circle is. Well, we know it's 360 degrees, so we'll take 40%. So remember, when we write that as a percent, it's 40 over 100. 40%. Percent is 100. And then that's going to equal how much out of 360? So this is going to tell us the degree. So how about I just put a D there instead of an X? That would be brilliant on my part. All right, so degree out of 360. So remember, when we solve this, just at this level, we can go ahead and just solve it 40 times 360 divided by 100. Because we've kind of already talked about our proportions and done this whole thing. So, you know, depending on the level that you're working at, but you're probably going to be doing this with a 6th grade class, I would say, maybe even 7th grade. So 40 times 360, and then we divide it by 100, and that gives us 144 degrees. So if we set this one up at 10%, we would have 10 over 100 equals what degree over 360. So cross multiply, 10 times 360 divided by 100, that's going to be 36 degrees. Same thing for 30. Okay, so 30 times 360 divided by 100 is 108 degrees. And lastly, we'll do 20%. And that's going to equal 20 times, this is 720 times 100, 7,200 divided, or 7,200 divided by 100, that's going to give us 72 degrees. All right, so you can check, these should add up to approximately 360 degrees. Now, once in a while in a pie chart, you're going to have decimals, and so that that is going to be an estimation and may not be exact, all right? The ones we're gonna work with though we're just gonna work with the whole, so you should be good. And then this should add up to a total of 100 students right here. And this should total 100%. So you can always check yourself to see how you did on that, because if you have an error in there, it's going to be an error in your degree. Now let me show you. Let me grab a piece of paper over here. Okay, so let me show you how to do a pie chart with that information. All right, so I'm going to try and keep that information on right here. Let's see, well, maybe try and do both. All right, so let's try and do both here. All right, so what you're going to need is you're going to need a protractor. And so I gotta find where my protractor is. If you don't have a protractor, you can just print a paper one off. Just Google printable protractors, and you can just get one and cut it out and use it. Okay, you only will need to use it maybe once on your test. So just print one off. If you have trouble, let me know. I can help you out. And so the only thing that I'm not going to require you is to use a compass, because usually you'll use a compass to make a perfect circle. All right, so if you want to like trace a circle with the bottom of a cup, or you just want to, try and do one, I'm just going to wing it here. Mine usually turn out to be ellipses. That's not great, but it'll work. All right, so it's not a perfect circle. Bear with me on that. Only because it's kind of hard to do all this online. All right, so here's what we do. We start with our center point on our circle, and we're going to go ahead and start with a line straight to the right. You could start one to the left if you want to, all right? But let's just go ahead. You have to have a starting point there. So we have this radius from the center of your point, all right, to the edge of your circle. Now, when you use a protractor, so the first one we're going to do is 144 degrees. So when you start this, you're going to line your protractor up. You're going to line your now see there's two different kinds of protractors. This one has double numbers, and you might get one with a single number. I think when I looked, you could get a double one. I would suggest that, but it's entirely up to you. So if you get a double one, you're going to line your center point up with this circle right here. There's a little circle cut out, and then this line lines up with your radius. All right, so let's line that up. Okay, and that's 0 degrees. Now the biggest question is, well, do I use the outside or the inside numbers? So you kind of, it depends on which way if you're opening to the right for your angle or you're opening to the left. So just use common sense and recognize if I'm doing a 144 degree angle, it's more than 90, right? So if I look here and I see, oh, here's 144 right here. If I were to draw that angle, connect it would be about right like this. This angle is not larger than 90. So I just have to kind of pay attention, because it depends which way my angle opens on which one I use. So I'm going to do 144. Well, here's 90. That's bright. And we're going to go 144, which is approximately right there. Okay, so I'm just going to put a light dot on the outside. And then when I connect, I'm not going to connect. I'm just going to connect to the edge of the circle. But I'll line the dots up. Okay, center point to the dot. Go to the edge. So this right here is going to be 144 degrees. And then this is the band. And I might include in there that it, and maybe up here, I'm going to title it Musical Students. Okay, and then inside here, you might want to put 40 students, because that's 40%, right? That's how many students are in there. All right, so here's where I drew my line. Okay, now wherever you end is where you begin your next degree. So this is where I ended. So I'm going to turn my paper and I'm going to start again right there. On the one that I ended is where I start. Now my next degree here that I have is 36 degrees. So I'm going to do 36 degrees. Oh, sorry about that. So I line this up and I look at 30. Here's 35, 36. Well, that looks reasonable, right? So from this point to here, that looks like about a 36 degree angle. So kind of use common sense on F. All right, so it kind of requires me to move my paper around a lot. So here's 36 degrees, and that was the choir, and that was 30. That was 10 students. All right, so where'd I end up? well, I ended up here. That's where I ended up. So my next one that I'm going to do is right here, and it is 108 degrees. So from where I left off, I line my circle up, my radius. I'm gonna go, here's 90 degrees, there's 100, 108, it's approximately there. You know, these are kind of sketches, so they're get as close as you can. And then draw, line it up to the points, and then just draw from the edge in. And that is 108 degrees. So right here is a 108-degree angle. This was the both choir and band, and it was 30 students. So lastly, I shouldn't have to do my last one, but kind of think about, my last one was a 72. Does that look about like a 72-degree angle? Pretty close, pretty close. And 72 was neither, and that was 20 students. And if you have colored pencils and you can color them in, that's awesome. And I think it's always great to have a key. And so you could do, if you did colors, that would be great, because it say this, you could color this blue, and you could do a blue square here and say band. All right, so if you can get some colors, if not, you might have to do something like this and just do some kind of a, so I would say, all right, so this, which is band, is band. Okay, so the purpose of the key is if I didn't really want to label band here, I could just put it in the key, and then I wouldn't have to have it here. So they would go, oh, okay, this line, that means band. So, you know, there's, if you do this labeling, you don't necessarily have to have a key. But I would like you to have a key and just practice making one either way. All right, so you can choose to put band in here or not. That's entirely up to you. So what I would maybe ask a student is say, what percent of the students, musical students, were band members? So I might have to figure out how to find a percent out of that. Well, I know there were 40 students, and I would have to know that there were 100 musical students. I'd have to have that on there too. Then you could figure out, well, 40 students out of 100, what percent is that? Well, that band is going to be 40%. And so maybe this would be my next one here. I can just do squiggle lines in it if I don't have color. So over here with the squiggle lines, that's going to be neither, and so forth. All right, does that give you a good idea on how to kind of get started on doing that? All right, so again, I do not care if you want to label this band or not, but either way, if you do or you don't, I want you to show me a key, okay? All right, so let me get you back to the notes. So, and that's our pie chart. So we're good with the pie chart. So going on to the next page, you can print these off. They're in our notes, okay, under pages. So now numerical data. So those that I just showed you, the pictograph, the bar graph, and the pie chart are all categorical data, okay? Doesn't mean they don't necessarily have numbers in them, but they're really talking about comparing categories. So a dot, when you use a dot plot, so now we're going to talk about the numerical type of data, all right? So for a dot plot, that's just like organizing a group of data, pretty much, but it's numerical. So I'm saying in here that the minutes to eat breakfast, well, it takes whoever it is to eat breakfast, there's 1, 2, 3, 4 of them that take 11 minutes. There's one of them that takes 12 minutes. All right, so that's a dot plot. Just seeing if that was any better. Okay. All right, so histogram. So a histogram, it shows how you can recognize when you're doing a histogram is it shows distributions of data, and it puts them, so you can compare them, but it puts them in ranges of data. So if you look at this histogram right here, I can get it a little bit closer for you to see that. So this, you see it's in ranges from 100 to 150, and from 150 to 200, 200 to 250, and so forth. All right, that's a histogram. It's still comparing, but it's numerical, and it falls in ranges of numbers. So histograms have ranges of numbers. And the other thing about histograms is that they connect, okay? And sometimes you'll see them not connecting. That's not a true histogram. They need to connect to each other. All right, so histogram should always, there should never be a gap where it says no gaps. And then lots of people get them confused with the bar graph. Well, remember, bar graphs are categorical. So I'm talking about categorical data here. All right, and they do not connect. They do have gaps in between them, whereas a histogram does not, and it's within a range of numbers. Okay, so that's kind of the difference there. A stem and leaf plot. So a stem and leaf plot, there we go, it's a little bit better. Sorry, I'm struggling tonight. All right, so with the stem and leaf plot, it just kind of, it's again, it's showing a frequency of numbers. Okay, and then it's kind of grouped according to their place value. So like this is all what this stands for. So you should have a key down here, and this says that 6-3 equals 63 years old. All right, so that means that 1-0 is going to be 10. All right, so this is always the number in the ones place. And this is the number in a 10. Sometimes you'll have a 2-digit number, and I'll show you that in just a second. So this would just mean numbers 0, 1, which means 1. So I have 2 1s, 2 2s, 1 3, 4 4s, and a 5 and an 8. And then, so just talking about what is my data? Well, I have 3 10s, right? And then an 11, 2 11s, a 13, a 17, and a 19. Got 2 25s, 2 27s, 2 28s, 2 29s. So that's just showing a way that you can display data and how frequently. Well, if I looked at that and I said, well, what number appears the most often? Well, I would look at that and go, I got 2 57s here, got 3 31s, 3 32s. Looks like to me 4 is shown 4 times. So 4 would be the number that's shown most often in that set of data. So eventually we're going to talk about central tendency, and we'll start talking about mean, median, mode, and those things in our next lesson. And that is something that we can find on here too. All right. And you can also look a little bit where you could almost see a bar graph in here, right? So when we talk about data skewing or something like that, we can definitely look at this like a sidebar graph as well. Now here is a double stem and leaf plot. Okay, sometimes they call them back to back. And that just compares 2 different distributions talking about the same thing. So whatever this data is, it's talking about boys and girls. All right, so now I notice I have 2 numbers here. That isn't always the case. That doesn't mean a double stem plot's always going to have 2 numbers here. It's just that we're dealing with 3-digit numbers. There's not a key here. So if I were to draw a key, I would say that 14-5 would mean 145. So I can read it to the right. So for the boys, I have 153, 158, 159, whatever this is. Maybe it's weight. I don't know what it is. 162, 165, and then I have 3 167s and so forth. So I could find the average of this data, right? Because I know what the numbers are. I just have to add them all together and divide by the amount of numbers there are, which is what we're going to do in our next lesson. Okay, then I could use those same stems, and I could then do, if I use those same stems, I could do that for the girls. It's just different because I'm reading it backwards, but it's still 145, 154, 155, 155, 155, 157. Okay, 160. It's just you're reading to the left, which is really kind of different. But it's just being able to display 2 different distributions, and you can look at them side by side and then compare them. All right, so that's a double stem and leaf plot. Another kind of numerical data is a line graph. Okay, it can be called a line chart too. Okay. And so this just allows you to kind of visualize something that happens maybe over time. That's an option, okay? And it just gives you a really good visual. And notice that it's connected, so that's why it's a line plot, line graph, line chart. I usually call them a line plot, but a line graph, they're exactly the same thing. All right, so it's just that they're connected, and it just usually is to show change over time. It's a good visual. Then we have a scatter plot. So a scatter plot is just a bunch of different values that are plotted. All right, so we're still looking at two different variables like temperature and ice cream sales. All right, we're just plotting them. So we're not connecting them like a line plot or a line graph. We're just connecting it to, just plotting the points, excuse me. So now I can say, well, is there a relationship between, the temperature and ice cream sales? So as the temperature gets higher, are there more ice cream sales? Kind of looks like there is, right? So you can kind of see a trend with that and maybe make a prediction with it. Now, sometimes you can't find a trend in there. You can't find a correlation between the two relationships. So what we've done is used a correlation coefficient, all right? And this really gets into our statistics. So if I look at something like this, to find this correlation coefficient, it's just a statistical measure of the degree to which changes to the value of one variable predict changes to the other variable. So if the temperature is getting hotter, we're going to have more ice cream sales, all right? So you can predict that by looking at the scatter plot and the correlation. So the closer the correlation is to 1, the more it's assumed to be a linear line, a straight line, okay? And now later, we're not going to really talk about the correlation coefficient, but really it's just, if I were to draw a line through this data, let's say I was here and I drew a line through the data, I would find the average difference from that to the line. And we'll talk a little bit about that later. I'm not as concerned today that you really know how to find the correlation coefficient, okay? But just knowing that the closer to 1, the more linear it is. So you can see here's 0.9, starting to get a little scatter, maybe something like this, right? It's 0.9. This is a low positive, so this is positive because the slope is positive. If I were to kind of put a line of best fit through there, it's still going to be positive, but it's getting a little more scattered, so it has a less correlation. Okay, this one doesn't have any correlation, it's just random scatter plot, and I couldn't really determine what's happening with this, okay, and considering in the change with this. So these don't have a lot that I can predict from because there's no correlation. So here's a negative 0.5, which just means the negative slope. So I can kind of see there's it's a low correlation, but I can see that it's going to be negative probably on that. This one's a little bit closer, and that's a negative 0.9. And then a negative 1 is pretty much a linear line. So you could look at a graph and I would say, what kind of correlation is it? Well, it's a high positive correlation. It looks pretty close. This would be a high positive correlation, okay? So that's kind of what I want you to answer. I don't want the numbers, but I would want this. And I'll talk to you a little bit again about these correlation coefficients a little bit later. In your calculators, if you've seen in the statistics, the R, that's your correlation coefficient. All right. So here's another, this is the last part of those notes. I just want you to be sure you kind of read through these so you understand the purpose and maybe when these are used, kind of which type of graph that you want to use when. These are in your notes as well. All right. So in your assignment, which I will post in just a few minutes, it's going to have you choose which would be the best graph for a particular set of data. And then I want you to be able to tell me if it's categorical or numerical. And then answer just a couple questions on it. Just you're gonna have to create the graphs, more or less. And then I included an example of a display of a graph that I saw just recently in the media, and I just asked you a couple questions about it, so you can give me some feedback on it. And that's on 15.2, and that will be in your pages, chapter 15 assignment folder. And then I will post this video on the my YouTube. So be sure when you click on my YouTube, you go to the playlist for Math 1105. Then you'll only have to just look through your own videos. You don't have to go through all the other videos I've done. All right, you guys, have a great one. We'll see you on Wednesday.